Good afternoon and welcome. This is our final presentation in the EBA Extended Virtual High Performance Home Summit for 2020. And today I'm pleased to be joined by William Ranson. William is the Building Knowledge Center leader at DuPont Performance Building Solutions. Beyond that, William is a founding sponsor of EBA. They're a sponsor of the Ultimate Zen Home, which you'll see throughout the summit coming up in the next 2 weeks. They're also a sponsor of our new initiative around an asthma and allergy certification program that we're putting together for another education module for EBA. And then we are also joined by Tom Bayada. Tom is a field development consultant at DuPont Performance Building Solutions. Today we have one AIA credit. I think you can email Nancy at eba.org for that AIA credit after today's session. And we will be talking about over or under the best options for installing both a weather resistive barrier and continuous exterior insulation. And just a reminder, we have at the bottom of the screen a Q&A section. So you can ask your questions there. I'll be asking those to William and Tom throughout the presentation. So without further ado, William, I'll hand it over to you.
Great, thanks, Aaron. So diving right into it, we'll be talking first about the why, and then Tom will take the second part, which will be the how of doing this. So again, I'm going to talk a little bit about code-driven, some of the energy savings and benefits behind this that we've actually measured in the field as well. And then Tom will be taking the second part with a lot of details on the wrap and foam combinations that we've done testing on to ensure that it's going to work correctly. So I believe most everyone's quite well aware of this, of the overall code process, but especially how it relates to exterior continuous insulation. About, first it's developed with some model code languages, then it becomes adopted by states, and some states are faster or slower or will modify the code adoptions by others. And then finally the enforcement by code officials, and then upgrading our literature compliance and having products out there to meet it, training people on how to do it properly. So the codes come out on a 3-year cycle. 2018 is the most recent ones that are out and being voted on by states and adopted by certain states. 2021 codes, they're through the adoption process and getting ready to obviously to launch those next year. And then we've got the links here at the bottom if people want specific information around some of the codes. And just a quick reminder about helping to understand which codes apply to which types of buildings. But again, here at EBES, we're primarily focused on single family or townhouse type 3-story and less. We're going to be talking about the International Resident Code and the IECC residential section of the code, but reminding you there's other codes bodies that apply for other larger type buildings as well. One thing that's interesting to point out here when we look at, and this is a 800 plus data points of the most common energy code violations, you see we've highlighted here number 1 and number 4, but almost half of them dealing specifically with issues around your building envelope and the R value of the wall itself. So either having improperly sealed penetrations, meaning you haven't put it together correctly, and then HVAC or somebody else came in and put some nice holes in your wonderful air water thermal barrier, or just not having the right R value that's required by the code. And so this is one we're going to be talking about some of what the code requires, and then Tom's really going to be addressing multiple ways we've worked to make sure that these are installed correctly as well. One of the positive things about advancing of the IECC is how much energy efficiency we are getting into our base homes now, which also can translate into HERS scores for, hopefully everyone's familiar with that. But if you start, with the baseline of the 2006 code, there was a goal overall you see for each of the years of a certain percent improvement of energy efficiency over the base code. And for the 2015 one, you saw they had a goal of 50% improvement, which is pretty incredible. Unfortunately, they only got 34, but on the flip side, fortunately, they had 34% improvement, which translates into a 34 point reduction in a HERS score of a home built to that 2015 IECC code versus a home built to the 2006 IECC code. And we'll talk about, there's lots of things that have put into the codes that help drive these energy efficiencies. But one of the largest ones, and what we'll be focusing on today, is specifically around exterior continuous insulation. You can see here for the United States, divided up into all its climate zones. Outside of climate zones 1 and 2, there are options in the 2012, 2015, and 2018 IECC for exterior continuous insulation. So what this chart here is showing, for example, in climate zone 5, and starting with the 2009 code, but especially with the 15 and 18 codes that are being adopted by most states now. So again, for climate zone 5, you would either need to have an R value of R20 cavity insulation or R13 cavity insulation, and the +5 is for +5 exterior continuous insulation as well. My understanding of the 2021 updates that we're working on is to even further simplify this language into what the +5 means, so that people don't confuse that with 13 and put another 5 somewhere else as well.
William,
but yes.
William, where I know states are adopting these codes, but what's just a quick overview for people on the call of where states are at as far as adopting the 12, the 15, the 18 IECC or IRC?
It's pretty wide variation, all the way down to some places like Arizona don't have one statewide code adoptions. But in general, and Tom, you can help me with this one too, but in general, we've seen that between 2012 and 2015, most every states have adopted up to that point. And then there's a few states who are leading the way on adopting the 2018 codes.
Great, thank you.
Okay, so this is the code we're talking about, but clearly you see as we move along with codes, it's continuing to recognize the importance in all climate zones, the benefits of continuous exterior insulation. So why are they putting into the codes? Why is this such a big deal? And really, the benefit of continuous exterior insulation is what we're showing here, which is reducing the effects of thermal bridging by framing. So on our wood frame building, up to 25% of the perimeter of the house is losing heat through conduction through the studs. It's equivalent to having one of your 4 walls not there to help with heat flow through the building. The picture we show here is just an example of, in the wintertime, on the left, you would see the conduction through the studs, the heat loss through the studs, versus putting continuous insulation to reduce that heat loss as well. Clearly, that's a generated image, but we have some real life scenarios coming up in the next couple slides of infrared images that show even in more detail what we're talking about. There we go. So here is one real life example where if you see the picture on the left, what you're looking at is a early morning after a cold evening, such that on the outside of the house, there's been condensation occurred. However, because of the thermal bridging, because the heat from the house is coming through at all the stud lines, it's warmed up the wall where all the framing members are to the point that there is not condensation there. Granted, this is a stucco siding, and there's other issues, I think, going on there. But what you're seeing here is, because you can clearly see the outline of all the stud lines, you can see that that's all the heat loss that's coming out of the building on that wall, versus, again, what was shown here is if that same house had continuous exterior insulation, it would not have anywhere near that heat loss or the moisture buildup that they're seeing on the stucco there. So it gives you benefits both in terms of better energy efficiency as your home, but also better durability of your walls as well, not having potential for moisture accumulation, especially in the colder winter months. And again, this is a similar concept to what I was talking about before. The benefits of exterior continuous insulation is simply that it keeps the wall warmer in the winter times, so that condensation, which occurs purely from a temperature-driven phenomenon, by having exterior insulation, the OSB or panel board or whatever your structural element is in your wall, by keeping that warmer, you lower the risk of there being condensation on the first surface that the cold air will reach, which is oftentimes the interior of the OSB, which will be right then where your bad insulation, and it's a really bad place to have water accumulating in your wall. And we know this happens because we've measured it. Here's a project where we intentionally had a series of homes all right next to each other in the same subdivision, all with the same general north-south facing elevations as well. And you see we had 5 homes that were built 2x6 OSB. So again, if you remember back to the energy codes, it gave you options of either a thicker wall with more insulation in the cavity, or the R13, so a thinner wall with exterior continuous insulation. So as you see, we had 5 homes here built with the thicker walls with all the insulation in the cavity, 5 homes built with the standard 2x4 walls with exterior continuous insulation. And then we put sensors on the inside of the OSB and measured the moisture content over 3 years of a cycle. Now, a couple things to add about this was all the homes were tested for blower door, all achieved relatively the same numbers, less than 3 air changes per hour at an ACH 50. They were in the 2.8, 2.9 range. So all were pretty similar there. But as each of them were occupied by people, the actual use of the home was slightly different. And we'll talk a little bit about that as we go into the results. So what this graph is showing here is over 3 winters, and the winters are the spikes where the graph bumps up, and I'll explain that why. So over 3 winters or 3 years of data, the y-axis is showing moisture content on the interior surface of the sheathing. And so what you're seeing here is these are for all of the houses that were 2x6 with bad insulation as well, no continuous exterior insulation. And what they show is the bump up in moisture content is always occurring in the winter time. Again, when it's very cold outside, it's warmer inside, you're having that thermal gradient, and the cold OSB is causing condensation on the interior surface there. Now you do see that it does dry out in all the summer times, but nonetheless, you're getting above 20% moisture content for several of the winter months. Interesting that winter of 2014, if people will remember, was one of those years when we had that polar vortex and it was really cold, hence the much higher moisture content levels you see there versus the other 2.
And William, where is this, what zone is this in? What town is this development in?
Tom, if I remember correctly, this was in climate zone 4.
It was either 4 or 5. It was in the Michigan area.
Yeah. Okay. Then it was 5. So I said then it was climate zone 5. One other interesting fact, as I mentioned before, that these were all actual operating homes, if you will, with families living in them, doing their own, setting their own temperature and doing their other things. There's one home, which if you notice, house 5 there, is the one home that actually does not go above that 20% moisture content. And upon further investigation, what we found was that home was occupied by a single elderly woman who was always cold and thus kept her house incredibly hot all the time. So she was having less of this moisture issues because, you know, she was in the wintertime keeping her house set at 78. You know, she had extra heaters running in her house because she was always cold. So,
William, quick question from the audience.
Yes.
Would this play out in reverse in climate zone 1 or 2? So would you see a hot, humid climate that actually you'd have condensation in the summer and that would be better in the wintertime? Or what's your thought there? Maybe Tom, that's for you too.
Tom, you can help with this too, but we would still also recommend this sort of scenario with continuous exterior insulation to help with thermal bridging. Yes, it could help some with the reverse of having condensation in the summertime from having a cold house and it being very hot outside, but also really my response would be it's based on how some of the homes were built in more of these southern climates, where the combination of exterior continuous insulation, when it oftentimes is a stucco house, is a fantastic way to help with some other water mitigation problems while giving you a good energy efficient building envelope. But Tom, did you want to add anything on that?
Yeah, William, I definitely agree. I think that question really pertains to inward driven moisture, solar driven moisture, which, like William mentioned, is a benefit of that exterior insulation certainly is to help block any of that inward drive. So you get that advantage there as well. The exterior insulation also serves as that secondary layer or intervening layer that we all know we need to have over our primary drainage layer. So there's some advantages there, like William mentioned.
So again, what we do to show this here is, this wall structure certainly does work, especially if you have an elderly woman who's hot all the time. But if we want to prevent our interior sheathing from ever getting anywhere near that moisture content, we move 4 houses down in the same development right here. And you see again for all 5 homes, and then the average line shown there as well. So exact same climate, exact same build, everything else the same, slightly different occupant use, but nonetheless a significantly different amount of moisture content in the wintertime on the interior of all these homes that had continuous exterior insulation. We did not, because of such varying use of energy bills, we weren't really able to compare energy use savings direct apples to apples comparison, but I would surely imagine that these homes we're showing here would have lower energy bills than if they were built as the homes were on the previous slide, being used by the occupants the way they were. Especially the woman who was keeping her home at almost 80 degrees during the polar vortex. I bet she had some monstrous energy bills. But we use these to show the benefits of both the durability as well as energy efficiency. And some other things about continuous exterior insulation before I turn it over to Tom to tell you how to do this properly with an air and water barrier is that oftentimes people forget that basements are terrible insulators. In fact, a wall of concrete is equivalent to about an R1, the same as a window. So you can have a lot of energy loss through your house, even the relatively small space that's exposed above ground. And we know this because we've seen this as well. The next slide coming up has some infrared pictures that shows this loss. But we've also modeled and proved with some test homes that simply adding R5, so very similar to what the codes allow as a +5 exterior option to meet energy code requirements. We've seen simply insulating a basement with R5 insulation as well gives you about an 8-point benefit and a HERS score as well, simply by adding R5 insulation to the basement there, which can be done, when the house is being built ahead of time, exterior of it, or added on after the fact as well. And when we said we've seen this happening in real life, this actually was one of our colleagues. I believe this was also taken in the Michigan area as well. So again, he did calibrate his camera so that each of these 3 pictures is on the same temperature gradient scale. And what he was looking at was, fortunately, being one of our DuPont colleagues, he did have DuPont styrofoam in his interior basement. So on the picture on the left in the middle, what you're seeing is somebody's vinyl sided house with a basement as well, and clearly no insulation in their basement. And you can see the massive amount of heat loss. This was probably a 30 below 30 degree morning when he was taking these pictures, because the temperature he's picking up on the houses in the low 30s versus his house on the right. Again, you can see the vinyl siding and you can see where it stops and transitions to his basement, but it's not that glowing 50+ degrees of heat loss coming out of his building. So we certainly realize that not only for foundations, but for exterior walls, putting a portion of your insulation outside of your sheathing, having the +5, or in some of the colder climates, the +10, it helps prevent thermal bridging, helps keep the walls warm, helps prevent condensation that can occur in the wintertime, and helps makes a more comfortable house, better energy efficiency, lots of benefits there. But there are some tricks on how to do it properly. And I think before I turn it over to Tom, if there's any last questions kind of either on the code or the science behind it, I'll take some of those.
Yeah, I think a great code question here, William, is what's the thickness of the R5 insulation that's required for continuous?
So my understanding is they don't call out specifically a thickness to achieve it. They just talk about R5 being that. But that being said, an R5 insulation, if it's an XPS, is going to be 1-inch product. If someone tries to use an EPS board, which is expanded polystyrene instead of extruded, you're going to need to go thicker because EPS does not have the same R value per inch as XPS board does.
Okay, so based on the code that we just saw with you, I can't use 1/2-inch rigid insulation on the exterior
Yeah.
and still meet the code.
I mean, you certainly can. It would give you benefit over nothing, but you would, going back to that one slide I showed before, that would not allow you to meet the +5 exterior continuous insulation.
So I'd still have to insulate the interior wall to the requirement, but it would help me push the vapor barrier out.
That's correct.
Other great question, and I'm in climate zone 6, so we deal with this here as well, but this is a climate zone 5 person, Thomas Harris, on the call. He said, interior vapor barrier is required when permeable insulation is used. Please discuss the effectiveness of the interior vapor barrier and source of the moisture. The drive is inside out, and maybe where are the sensors located?
Okay, so in that scenario that I showed the examples from, the sensors were on the interior side of the OSB. And a good question again, that we do get asked a lot about interior vapor barriers, which by code are required in the colder climates as well. But if you imagine your wall system from a vapor diffusion point of view, having an interior vapor barrier here, an XPS board on the outside, your continuous exterior insulation, there's really no vapor movement in either direction between your walls. So as long as you've installed the product when your lumber is not dripping wet, which no one would recommend doing, that wall will function the same way, if you think about it, as a metal roof panel does, which we've been using for years, that has vapor barriers on both sides, if you will. The problem that a lot of people have when they have an interior vapor barrier and something like XPS on the outside, and they run into problems, they're actually running into problems with air leakage, because air leakage, especially from the inside, brings an incredible amount of moisture into that wall cavity as well. So we've seen that the critical point to getting this right is during construction, as they typically weatherize the exterior of the house first, if it had been raining while this was going on, for them to make sure to dry out the home to the inside before installing the interior air and vapor barrier as well. And then at that point, they have a very durable wall structure that our colleagues in Canada have been building for 30 plus years with no problems, again, when done correctly. So I think I addressed that.
Yeah.
Tom, anything to add to that one?
No, I don't. I think you nailed it.
Okay. You can disagree with me. It's okay. Tom and I have worked together since he was in college and not long after I was in college. So
absolutely.
I'll turn it over to you, Tom, to kind of go through your part of how we make this happen.
All right, so yeah, again, Tom Beata here, part of our technical support team, and have actually worked in the development in some of the details of the how, right? So hopefully you understand some of the basics around why you want, why exterior insulation is a good idea, but then how do you go about implementing that and executing a good installation on your homes to make sure that the details are being carried out correctly, that you're air sealing, as William alluded to, and installing the products in a correct order. So you may be asking, what is that correct order? So we want to go into that a little bit here. So this is all based off a document which we created to cover essentially all the considerations around installing a typical Wrb Wrb with the exterior insulation. And so you can kind of see the breakdown of the document there on the left as far as what's covered. For the purposes of this presentation, I wanted to focus on a few of the key areas and really highlight some things to consider from an installation point of view. And I'll back up just a second. This does and is aimed primarily at single-family homes and lower-rise wood frame buildings, multifamily buildings that are essentially built like a big house, right? So you think you're garden-style type of building. So certainly applies to townhomes as well. So next slide, William. So kind of as we get into those categories, right? So starting out with some of the general considerations, essentially what I have here on the left is the text from the document, but want to highlight some of the key areas and considerations that you're thinking about. we always talk about the WRB and where the flashing should be in relation to the WRB. Of course, you want the flashing on the same plane as the WRB so that you create one continuous drainage plane down the wall path, so that any water that maybe get behind your cladding, whether it's a vinyl siding, a fiber cement siding, even brick or stucco, you have that continuous drainage plane that directs water out and away from the building. So you want to carry that same principle here when you're installing exterior insulation. And so when you're doing this, there's multiple ways to do it, right? You can see in the bottom right there, we're showing a simple view of exterior insulation either over the WRB on the left or the WRB over the insulation on the right. And so what we want to get into is a wall is built as much more than just that opaque wall that you're seeing there, right? It has windows, it has dryer vents through it, pipes. So we want to make sure that we're considering all the different parts of a wall assembly so that it can be executed correctly and we don't have any issues. And so the again, keeping the flashing on the same plane as the window is critical. And so that really is what helps you determine where your insulation will be in relation to the WRB and how to carry that out. So for instance, one detail that comes up is that if you have your WRB on the main wall plane at the OSB level and the window is installed to that, then you're once you install your insulation, depending on the thickness of the frame of the window, those windows may be recessed a little bit, and so you'll need to take some precautions around protecting the insulation around the perimeter of the window with an exterior jamb extension to make sure that the insulation is protected and you have your aesthetics of the building as well. Next slide, William. So as you get into what this really looks like, what I was talking about here is having the windows either aligned with the finished wall or recessed from it. And that's really within this document that I mentioned is how we've split up the different applications. And so when you look at how you get your windows planed back out to that exterior wall, again, regardless of cladding, there's a few different ways to do it. And it can be either under or over the insulation, the CI, continuous insulation. In order to have the WRB under the insulation, though, and align the windows with that wall, you're going to have to bump out that window. The window is going to have to be brought out the thickness of the insulation to plane it back out with the cladding layer. So the first bullet point you'll see there is that a bump out will be needed, and the flashing details become more complex because you're trying to flash around that bump out and ensure that you have continuity from the bump out, the window flanges for a typical integral flange window, and then back to the main wall plane. So how do you do that? And we'll go into that a little bit more detail. The reverse of that, of course, is if you put your WRB over the insulation, like what is shown in the picture there, it simplifies some of those details. And we'll get into that as well, but you can see that that detail looks pretty similar to your typical window installation method, with the exception of the bump out. And we'll talk a little bit more about when you can consider bumping out the window or putting wood bucks around the window versus nailing directly through the insulation. So there's options there that we want to consider as well. I already mentioned some details around the windows being recessed from the exterior wall, but in this case, anytime that the windows end up recessed from the exterior wall, you are going to have the WRB under the CI. And so because you have WRB behind the CI and you're creating that WRB again to be your primary drainage plane, you want to make sure that you're promoting drainage as much as possible. So we typically recommend a WRB with some sort of enhanced drainage, whether that's a product like the DuPont drain wrap that is a crinkled type nature, and there's other products out there that also enhance drainage as well. But it's always a good idea to increase drainage as much as possible within any wall assembly, again, to promote drying of the wall assembly. And so, again, looking at the sorry, William. One more point here on this slide. Looking at when you would be flashing those windows, of course, those would be flashed and completed prior to any installation of the continuous insulation. So as you start to then think about how do I fasten the different layers, and what are the differences between the WRB being underneath the insulation versus the WRB being over top of it. And so what I have on the right here are the two diagrams explaining that. On the top you have the WRB installed underneath, and then below you have the WRB installed over the insulation layer. And so there's a few considerations there, right? There's considerations around when these different materials are being installed. Of course, we always, as much as possible, try to promote minimizing the number of overall penetrations through your WRB layer. And so there's different methods for doing that. So you can imagine on the top there, the staple that's being shown for the WRB fastener, if you're installing that insulation shortly thereafter the WRB, you could use a temporary fastening method as approved by the manufacturer to more or less tack that WRB on the wall until the insulation is then installed over top of that to install the rest of the fasteners that will then help to cover that WRB and hold it in place. A similar type of consideration for just the opposite, right? When the insulation is installed first. Insulation, of course, is very light. And so if you're putting the WRB over top of the insulation, you are going to be installing with a longer fastener, likely a cap nail. So for the WRB fastener that's being shown in these diagrams, you'll notice that the staple is shown up top versus the nail at the bottom. And that's one point we'll talk about a little more. But the insulation can be installed with minimal fasteners before the WRB then goes up, because the WRB is now the outer layer and would follow a more typical fastening schedule for the WRB. So there's different considerations, like I said, for when you're installing these different components. If you do expect a longer period between, say, you're installing your WRB first and then the insulation, if you expect a longer period before the insulation is installed over the WRB, you probably want to consider a full fastening schedule for that WRB, just to ensure that it stays in place as designed and you don't have any issues with wind or blow off or anything of that nature. I see a question here. It says, so on current stacked wall detail image, both of the WRB would have to be the crinkle type. They would not have to be. So for specifically from a WRB manufacturer point of view, it would be recommended for the top one where the WRB is behind the insulation. So that's where you would have the crinkled type, as you mentioned, like a DuPont drain wrap, Tyvek drain wrap. The one on the bottom, I think you're most likely thinking through that we're showing a siding there, like a lap siding. And the recommendation there is primarily driven by the siding manufacturer. DuPont, as a WRB manufacturer, does not require it. However, we do recommend it. So hopefully that answers that question. We'll continue moving to the next slide, please, William. So we talked a little bit about the WRB.
Tom,
yes.
Just a quick question from Jeffrey Luoma. He says he has the compressed wood particle board underneath the siding. It doesn't hold a nail that well. Any experience with keeping this or changing it out? And I believe your comment was you got to mark and hit your studs on that, but please answer that one.
Yeah, that's a good question. You know, you are going to have varying substrates depending on the time of construction of the building, whether it's a reside building, new construction. So certainly, yes, the recommendation in that case would be if you don't have a substrate which has the nail holding power that you would otherwise be looking for, like an OSB, you would absolutely need to then make sure that you're hitting a stud to make sure that you have adequate holding power for either the Wrb layer or the insulation layer. So that's where, again, we're showing kind of some the penetration there into the stud. And then the next slide here actually talks about that penetration depth, specifically for the insulation. So we're showing the styrofoam, again, the XPS, extruded polystyrene insulation. And so when you're thinking about the depth of that, we're talking about a penetration into the framing member, a minimum of 3/4 of an inch. So if you have an inch of insulation, XPS insulation, again, equivalent to that R5 per the code requirement, and at least in certain climate zones, you'd be looking at an 1.75 inch minimum. And that doesn't even factor in, right, the thickness of the sheathing. So it would be actually probably about a 1/2 inch thicker than that. So that's where you're factoring in really the thickness of the insulation and increasing your fastener that much more to ensure that you're getting adequate holding power there. And so the recommendation for the types of fasteners for insulation, there's different methods or fasteners that can be used. Even down to a typical 3/8 inch head galvanized nail. The best recommendation would be a cap fastener. Of course, you get much more holding power, as well as you reduce the likelihood that that fastener is going to penetrate further through the insulation than you want it to. You want it to sit flush with the insulation to help hold it in place. And so taking that into account, you can again get back to reducing the overall number of fasteners. You'll see in the depiction there that at the intersection of boards, you're actually seeing just one fastener. So if you have that cap fastener, even a 1-inch fastener, you have the ability to basically span that fastener across 2 boards, again, just simply by the nature of the weight of the boards themselves. Just again, making sure that you have a minimum of 2 fasteners at the intersection of 3 or more boards, really just to hold that intersection together. And the note there at the bottom of the of this particular slide, again, really points to reducing those fasteners. So I mentioned the insulation of the Tyvek, the installation of the insulation, but what about the fasteners for the cladding, right? When is the cladding going up? So if you have, as depicted in this diagram, you have Tyvek on the wall, you have your insulation. Can you minimize the number of fasteners for the insulation, even if you have the cladding going on shortly thereafter? And so these are things that are beneficial to take into account. Next slide, William. So one interesting thing that as we were developing these details, we realized we have, of course, flashing products to seal pipe penetrations and other details. And so as we were thinking about some of these smaller penetrations that, again, often can be made late in a construction process, right? If you have an HVAC and you realize you haven't quite put a vent where you need it to, or a dryer vent where you need it to, it's easy enough to drill through the wall and put that penetration where it needs to go. But how then do you seal it? How do you make sure you have that same level of air and water holdout if you have the Wrb now installed behind the insulation? So that's what this depiction is showing here, is that if you have a penetration like a pipe penetration that's drilled through the wall late in the process, the reality of the practice then really to seal again back to your drainage layer, which is the Wrb, is removing the insulation around that area so that you can access the Wrb to seal off to it around whatever that penetration may be. So we'll talk a little bit more about some of the advantages and challenges of the different installation methods here. Clearly, this shows an advantage for installing the WRB over the insulation, because in that case, if that penetration through the wall is made late in the process, your WRB is already the outermost layer. So you would just be simply sealing to the WRB layer like you otherwise would in your typical construction practice.
Tom, is it best practice still to, what we used to do when I built was all the penetrations had to be done before the weather resistant barrier went onto the house, so we didn't face that problem. Is that still the best practice that you recommend?
Yeah, that's absolutely the best practice, and that happens 100% of the time, right?
No,
So,
it doesn't.
the reality is some things change, right? You might
Yeah.
get an RFI or something changes late in the process of the construction of the house, and that's just the reality of how construction goes sometimes, unfortunately. So, these are just things, again, you think about, maybe call it forgiveness of the construction practices, right? How are you accounting for those things, and are you ensuring that your trades are easily going to be able to seal to this, and what's the likelihood that they're going to take the time and effort to do so? So these are some of the considerations you can kind of think through in the overall design and sequencing of materials.
Great, thank you.
So this is a little bit of a busy chart, but again, I spoke to advantages and challenges, right? So when you think about the columns here being WRB under CI, WRB over CI, and then the advantages and challenges of each. I'll start with the under CI and advantages. So again, you're installing your WRB first, so it's going directly over, probably you're having OSB or plywood as your sheathing, so your fasteners are going to follow a standard installation like they always have, right? So it's a little bit of advantage from that standpoint. And then I mentioned also that your WRB layer can be installed with a temporary fastening method if the insulation layer is going to be installed soon thereafter. And of course, all WRBs are susceptible to UV light. It's just the nature of how polymers work, right? So we have to take that into account. So the foam actually helps to provide that additional protection. So if your trade is installing the WRB as well as the foam, and you have a separate trade for your siding, depending on scheduling, that foam can help protect that WRB layer and ensure that you're not going beyond the UV limits of whatever WRB you may be using. As far as some challenges with the WRB underneath, I spoke a little bit, obviously, about having that difficulty with a penetration like a pipe penetration that could be made late in the process. So as much as possible, to the question a minute ago, you want to make sure that you're addressing all of those penetrations beforehand. And we'll get into certain installations where if the WRB is under the insulation and you want your windows to be on the same plane, that does require a bump out detail, which does have added complexity. As far as WRB over CI, you can kind of quickly visually see, right, some advantages versus challenges. And really, we found that there are a lot of advantages of WRB over CI. Your window flashing details tend to follow a pretty standard practice as far as the installation method, which we'll get more into in the next slides. We talked about the advantages around penetrations and managing those much the same as you otherwise would in a typical assembly. You have your drainage plane directly behind the cladding, so that there's not another layer there. From an inspection process, or if you have a third-party inspector verifying the details of your installation, of course, it's going to be much easier to observe that installation if the WRB is over the CI. And then again, going back to the number of fasteners, the continuous insulation fasteners can be reduced when initially installed. And really, when you think about the challenges, the main challenge there is just making sure that you have those longer fasteners for the WRB, because it's going over the CI, that you're just accounting for the thickness of the insulation to make sure that you're getting back to a solid nail base for holding the WRB into place. Okay, so we talked about the different methods for installing the insulation, the WRB. Is it under? Is it over? And how does that affect the windows? And this is really a key area, right? So we broke that down into 3 sections. Certain areas of the country, the windows are installed before the primary WRB layer. Versus afters. And so that's the split on the right versus the left of these 2 tables. So we did account for that as well as the CI under and over. And we'll get a little bit, and we're going to break down each one of these sections here. I do have a note at the bottom. I mentioned this a little bit earlier. In terms of installing a window over the insulation, do you need to bump it out, right? Do you need to have a wood buck there to directly nail the window into if it's an integral flange window? And ultimately, that's going to come back to the window manufacturer. Based on our internal testing, as long as you've accounted for the thickness of the insulation and are getting that adequate penetration back into the stud for structural support of the window, we have testing to show that if the insulation thickness doesn't exceed 1.5 inches, that can be considered. But ultimately, like I said, it is going to depend on the window manufacturer and their recommendations for their particular product. So you definitely want to make sure if you're considering installing a window directly over the insulation that you've made sure that the window manufacturer is okay with that as well. Next slide, William. So again, going into the methods of the different sections here, the 5 sections. The section 1 and 2 again is showing the methods when the windows are installed before the primary WRB layer. So you're basically addressing and flashing windows before you're putting the rest of the WRB on the wall. And this usually comes down to sequencing of trades. But if you're combining that now with the installation of insulation, how do you do that? And so looking at section 1 on the left, having the windows installed before, and then you want to align them with the exterior wall. The best way to do that is to have the insulation behind the WRB. So the basic breakdown of the layers is, again, adding that solid wood buck if needed. The insulation layer, protecting your window sill with a product like Flex Wrap or some other sill protection method, installing and flashing the window, and finally installing the WRB and sealing it off to the flashing is the sequence of materials for that type of method. If you look at section 2, where you're installing the insulation over the WRB, and you're not bumping that out, you are going to have that situation where you have the window potentially recessed from the exterior wall, and things like exterior jam extensions may come into play. So back to a question earlier, we are showing the crinkled type of wrap there, the drainable wrap, to help promote that drainage between the layers. Next slide, William. And so I'm highlighting this particular slide as one of the methods that I think is going to be more common, and it also shows the installation of the WRB over the insulation back to some of the advantages around that. And so if you really look at the breakdown here, again, of the sequence of layers, it's another scenario where, again, you consider whether or not a wood buck bump out would be required prior to the installation of your insulation. And then once you've installed the insulation, installed the WRB layer, and then you install your window, again with sill flashing, and then with the flashing of the jambs and head, and then finally sealing off the head flap. This is a method that I say is most likely more common, again, depending on certain markets, geographic areas, climate zones. This is showing the windows installed after the WRB. So sections 3 through 5 show the installations with the windows installed after the WRB. So you don't have, if you noticed in the previous slide, there's a skirt method or an apron method that the sill flashing is integrated with in order to bring that out to the outside, and that doesn't come into play when you're installing the windows after the WRB.
Tom, we
So
have a couple questions.
yeah, sure.
Do you want to take those on this slide, maybe?
Absolutely. Yep.
Thank you. Do you want me to read them to you?
Yeah, I have it pulled up. I can actually read it. So I see Thomas Harris has a question. Do you have rough cost numbers regarding the difference between under or over? What are the percent savings? What are the general costs per square foot? So I think the underlying question here comes down to cost. I would say overall the material cost is going to be the same. I think it's really going to come down to the trades as far as labor, and there's a lot of different, there's a lot of variability there, right? And it all depends on who's installing what product. So I can't really speak to, unfortunately, the overall cost advantage from a labor perspective of over versus under. Just more so from a practicality standpoint are some of those advantages and challenges.
Well, I think
if you are interested.
some of it, Tom, goes back to your fastener recommendations, right? So if you're smart, fasteners are a big expense. If you're smart about your fasteners and fastening both at one time, that's going to save you on installation, right?
Absolutely. That's a really good point.
Great.
But if you do have questions, regarding the materials, certainly you can contact your local manufacturer's reps. And I see a question here from Sam. Hopefully I'm pronouncing this name right, Petapinki. The advantage of WRB behind the insulation is to move the dew point out of the wall cavity, correct? So that's a great question. And really, I think you may be thinking through where the installation is relative to the sheathing versus where the installation is relative to the WRB. Essentially, the R value of the WRB is negligible, so it's not contributing significantly to the dew point, moving that dew point within the wall assembly as much as the insulation is. So as long as you have the insulation there, all things else being the same, you still have an insulation, you still have a WRB. So it really comes down to the overall thickness of the insulation and type of insulation, whether you're getting that R5, R10, or beyond, to where you're really, to your point, moving that dew point. So hopefully that helps to answer that question. So I think we were, if there aren't any more questions, I don't think I see them, at least in the Q&A section.
No, we're good.
The slide here shows just what a real-world scenario of that would be. Again, if you are installing that wood buck bump out, you're installing that first, then the insulation. To the point about fasteners, you can see that there's a few fasteners around the perimeter and a couple there closer by the window frame, just to hold that insulation in place before the WRB is then installed over that. Once that insulation is there, like I said, it essentially becomes the sheathing, right? So you're just, the insulation of your WRB is more or less the same as it would be over any other sheathing. So typical eye cut with a head flap, install your window and flash it per conventional methods. And so that final picture there is just showing the cutaway of what those different layers look like. So section 4 here, again, this is a windows installed after the WRB layer is installed. And we're looking again at the situation, if you have the WRB behind the insulation or under the insulation, we're looking at a recommended drainable wrap, installing and flashing the window, and then installing the insulation. So of course, this is the situation then where you may need to consider those jam extensions from from the exterior, depending on the recessed amount of that window. And then finally, this is I believe this is a fairly common, at least in my experience, supporting mostly multifamily construction. I've seen this detail used fairly commonly, where the WRB is installed, but again, they want to move the WRB is installed over the sheathing, but again, they want to move the window to the plane of the cladding layer. And so if you have the WRB on the sheathing, yet you want the window to be on the main layer, you still have to integrate your flashing back to the WRB. So that's going to require you to bump out that window and then use a different detail to flash around that bump out in order to make it air and water tight. And you're doing all of that prior to the insulation going on. So you're doing a lot of I would say from a labor standpoint, you're doing most of the work for the layers there, especially around your flashing details, with your last step being the insulation, and then of course finally the cladding would be going on. And so the slide after this, I have a breakdown of what that process looks like. So if you look at installing your WRB first, there's different methods for treating a bump out. DuPont has several methods for doing so. Again, this is a method, if you look closely, you can see that the Tyvek is wrapped into the opening before the bump out goes on. But in some cases, you may have those bump outs on the wall before the WRB is installed. So there's different methods for accounting for those types of details as well. But nevertheless, you have the WRB layer installed, you have a bump out, and then you begin to flash the opening. Of course, you need to protect the sill before the window goes in. So you can see there right away that you're doing some more complex flashing details to start to build out from the main plane of the wall to that sill, which is now on a different plane, and trying to make sure that that is all sealed up correctly. So there's different methods. We're using a piece of the WRB, an apron, versus the image to the right of that actually shows, if you look closely, you'll see that there's actually flashing there. So there's different methods, again, taking into account cost of materials versus the ease of installation. I've seen, there's preferences for both. So we have options for both. So really the second picture shows the flashing method before the window goes in. Once the window goes in, you end up with several more pieces of flashing, right? Because you're going again from that WRB layer on the main wall plane over that bump out plane and then over onto the flanges of the windows. And you're doing that around the perimeter of that whole bump out area to make sure it's fully encased, because you now have to treat that as a part of the drainage plane. And then, of course, you're integrating back to the sheathing above the bump out now prior to sealing your head flap, again, to account for proper shingling of materials. And so, like I said earlier, the last step, once you complete all those flashing details, you're installing your insulation layer. So I believe that is all the slides that I have as far as execution for carrying out some of these details. So hopefully you found that helpful. I'll take a break now and see if there are any additional questions.
It's fantastic. I think I posted the DuPont Knowledge Center, but are there places where, I think it's always helpful before you go to install, the continuous insulation and WRB in your windows, that you almost look at a video or look at some cutaways. Is there a place to go on DuPont Knowledge Center for people to find that information?
Yeah, so we have several different areas you can go. So we have a resource center that you can get from the main DuPont page that will have all your installation guidelines, including the particular installation guideline that has all of the details I shared today. But as you mentioned, Aaron, another good resource are animations. So the construction instruction, if anyone is familiar with that app, it's a fairly well-known app, I believe, available on your phone, available on your computer. there's actually a lot of animations that show different installations, and we're actually in the process of finalizing some new animations right now to cover these exact different scenarios, all 5 of them actually. So those are coming very shortly. They're not out yet, but I would definitely recommend taking a look at that app, because there are existing videos out there or animations out there that show do a really great job of showing the process of different installations, and really help folks to understand in the field. You don't have to read it, right? You can see the step-by-step process. You can pause the animation. So it's a really nice tool in addition to our installation guidelines that you can find on our website.
Fantastic. Is there also local training available if people want to go to, you go to the local lumber yard and you can do hands-on training on proper installation? And then are there certified installers as well?
Absolutely. So throughout the nation, we have a group of about 160 plus what we call Tyvek Specialist. So these are highly trained salespeople who part of what they offer is helping folks to understand everything that we shared here today. They offer trainings as well as job site observations to make sure that things are being installed and followed correctly at that job site. If there are areas for improvement, they can certainly help with pointing those out and correcting them. So it's a really great resource that is available certainly in your individual market. So if you are interested in that, you can just search Tyvek Specialist Locator on Google, and you'll be able to find it, and you'll be able to put in your area code or zip code rather, and you'll find your local person.
That's fantastic. William, maybe you can talk a little bit. There are some great videos that we're going to have posted for the EBA Summit on the ultimate Zen home, and Zen stands for Zero Energy Now. And that featured DuPont products on it. Maybe you want to talk a little bit about that particular installation, and then tell us what's new from DuPont that we can look forward to. I know we were talking as we prep for this meeting about some new products, but can you give us a quick overview on those 2 things?
Sure. So again, what we've shown here and what's featured on the Zen Home is, again, the benefits of weather-resistant barrier, water-resistant barriers like Tyvek, especially Tyvek in combination with exterior continuous insulation to help give you the energy efficiency improvements as well as the durability improvements on keeping the wall warm and thus dry throughout winter as well as summer. I think one of the benefits that getting a homes as we move towards building homes cost effectively that are net zero ready is this is the start. Step 1 is getting a good thermal barrier, a good air and water barrier protecting the structure. But then from that point, your next step, and this is why we announced at the beginning of this year a collaboration we're doing with Train Technologies, are on making sure you have a proper HVAC, especially the ventilation strategy, because you use, for example, all of our products with the help of our specialist network to get a good air, water, thermal barrier. Now you've got a nice, tight, energy efficient home. We need to make sure your heating and ventilation is now properly sized so that it's not too large, short cycling, and not getting the humidity out of the home. And at the same time, capturing additional energy efficiency while also having a good ventilation strategy, because just putting a fan in the bathroom is not a ventilation strategy for a home with a very low ACH score. So that's one thing. While we're excited working with EBA, while we're excited to partner with Train as well, we'll be rolling out more things with that next year. I would say on top of the few products we've launched over the past years, the largest product change we've got coming that everyone will see starting just January this year is we're changing the formulation on our XPS, so it'll be a lower global warming potential product as well. Unfortunately, the blue boards that everyone has come used to calling them will now be gray, but they will have all the same R value, all the same physical properties as well. It'll just continue to be better for the environment, which is another great thing that we're going for.
And are you using an HCO for a blowing agent then? And what's the global warming potential on that? I think it's 1.
No, it's not quite 1, but it by next year we'll have a product that will be below 150, which is what most of the states have been moving towards. Okay. And I think then lastly too, we just launched last week because also part of our DuPont portfolio is a product called Corian Endura, which is a new one of our solid surfaces within the Corian brand as well, which is based on porcelain technology. So heat, scratch resistant compared to a lot of your solid surfaces, as well as essentially zero VOC. So again, providing a better indoor air quality experience for your home.
Well, what I love about this new product in particular is we're seeing so many builders and architects and homeowners that are concerned about health and wellness in their homes. And this is actually a certified low VOC product, is it not?
Yes.
Okay. So, we talked about that ventilation strategy, the partnership between Trane and DuPont, but, to have low VOC products, low off-gassing products in the built environment too is critical. So it sounds like a great product.
Yeah, we're expecting to be very successful. So thanks very much. Are there any final questions?
No, I think that's it. I just want to thank both of you for presenting today. Lots of great stuff. I think that, my key takeaway is, the continuous installation helps move the condensation line out further away from the building and presents long-term problems. So I just want to add that we are starting the 2020 virtual summit. This has been the pre-summit, but the virtual summit main portion starts on Tuesday morning at 9 a.m. Our first session will be Zero Place, making net zero energy homes mainstream. And we, of course, wish we could be with everyone this year in Denver, but we will be back in Denver next year, September 14th through the 16th. And actually the Ultimate Zen home, which is a completely electrified, decarbonized home. It's really all of these best practices put into one. We partnered with Thrive Home Builders on that, with Pro Builder Media on that home. We'll be sharing that with you again when you come visit us in Denver. And I always say, COVID willing. So William and Tom, thank you again so very much.
Thanks. Have a good afternoon, everyone.
Take care, everyone.
Thanks, everyone. Appreciate your time.